Welcome back to the deep dive. Today we're shifting gears a bit, moving from pure software into, well, the really high-stakes world of industrial automation.
Yeah, absolutely. Big implications here.
We're diving into a pretty significant milestone for anyone working with the IEC 61499 standard. It's the feature freeze for Eclipse 4diac version 3.0.
That's right.
So our mission today, we want to cut through all the announcement jargon. We've looked at the official stuff, the nates, and we're going to distill it down. What are the core technical wins? And maybe more importantly, what does this actually mean for you if you're an architect or a developer using this?
Right. We're aiming for that shortcut, the key takeaways you need to know right now.
Exactly.
And maybe we should start with that term, feature freeze. In the industrial automation world, that's, well, it's a big deal. It signals a critical shift.
How so?
It means the team stops adding new things, stops adding features, and pivots entirely to stabilization, testing, polishing, making it rock solid. For industrial control systems where reliability is everything, this phase is absolutely crucial.
Okay, so it's like locking down the blueprint before you start the final safety checks.
Precisely. They're basically saying, this is what's going in the box, and now they focus intensely on making sure that box is trustworthy for potentially critical tasks.
Got it. And to give a sense of the effort behind this, I saw a stat that kind of jumped out at me. This wasn't a quick update.
No, definitely not.
It involved over 2 years of development work. And get this, more than 7,200 commits in total across the main components.
7,200,
Here.
yeah, that's substantial. It really underscores the scale of the changes and the community effort involved. It's not just minor tweaks.
No kidding. So let's try and unpack that massive number. Where did all that development effort actually go? What does the breakdown tell us about their priorities for 3.0?
Well, looking at the numbers is quite revealing. The lion's share, over 5,800 of those commits, went straight into the FORTE IDE. That's the integrated development environment.
Okay, the user-facing part.
Exactly. The tools developers use every day. Compare that to the runtime engine, FORTE 4TE, which got over 1,400 commits. Still significant, but the focus was clearly weighted towards the IDE.
So the message seems to be modernizing the developer experience, making it easier, maybe safer to build these systems.
I think that's exactly it. They put a huge emphasis on modernizing how developers interact with the system, how they build applications, and ensuring it aligns well with industry standards like IEC 61499 and 611313. That's often a hurdle for teams adopting new automation platforms.
Right, smoothing out that adoption curve. And speaking of moving forward, I also noticed the release timeline seems quite ambitious. They're aiming for the official 3.0 release just about 3 weeks after this feature freeze.
Yeah, that is a tight turnaround. But, it's actually a strong signal.
How do you mean?
It signals confidence from the development team. It suggests they believe the core changes are stable, that the integration of all these new features hasn't fundamentally broken things. They're not budgeting for months and months of fixing critical bugs discovered post-freeze.
Ah, okay. So they're likely in that final phase of integration testing, documentation, maybe minor bug fixes, rather than major architectural repairs.
That's the implication. For you, as a user, it suggests you can probably expect a pretty reliable release fairly soon, right out of the gate.
Okay, that makes sense. Let's dive deeper into that IDE then, since it got so much attention. Section 2 in our notes, the announcement mentioned a wealth of new functionality and improved usability. What are some concrete examples that will change a developer's daily work?
One of the big ones, especially for larger projects, is improved code maintenance. They've added proper refactoring support.
Refactoring, like renaming variables and functions safely.
Exactly. And crucially, it works across both the graphical editors, where you wire function blocks together, and the textual editors, like for structured text. Imagine you need to rename a key interface variable used in dozens or hundreds of places.
Oh, wow. Yeah. Doing that manually is tedious and super error-prone.
Totally. So having automated refactoring tools that understand the links between graphical and textual code, that's a massive win for reducing technical debt and just improving overall code quality and maintainability.
Okay, that's a solid quality of life improvement. But what about stability and working with, say, code from others or older systems? You mentioned validation improvements, specifically loading and repairing incomplete projects. That sounds interesting.
Yes, that one tackles a common headache in the IEC 61499 world.
Yeah.
Because the standard encourages reusable components, you often import function blocks or libraries from elsewhere. But sometimes well, sometimes they aren't quite complete or have minor compliance issues.
Right, which can break your build or lead to weird runtime behavior.
Precisely. So the new validation system is smarter. It doesn't just flag errors. It can actually help you repair some of those common issues in incomplete or slightly non-compliant imported projects.
So it turns what could be hours of manual debugging and guesswork into something potentially automated.
That's the goal. It makes reusing components and integrating third-party libraries much safer and faster, a huge usability boost.
Okay, this sounds like a theme making things easier and safer. Now, you mentioned IEC 611313 structured text earlier. That's a huge standard in traditional PLC programming. What specific improvements were made there?
This is another area where they did a major overhaul. The whole structured text editing experience is modernized. But the really big news, I think, is the new interpreter they've added.
An interpreter, what does that allow you to do?
Okay, so think about how you'd normally test the logic inside a function block you just wrote in structured text. Before 3.0, you'd typically have to compile it, deploy the whole 4diac 4TE runtime onto some target hardware, connect your IDE, and then try to monitor the execution.
Right, a multi-step process just to see if your algorithm works.
Yeah, kind of cumbersome, especially early on. But now with this interpreter, you can test and debug the structured text logic of your function blocks, your FBs, directly inside the 4diac IDE itself.
Ah, so you can run the logic without deploying to actual hardware, like a local simulation just for that block.
Exactly like that. You can step through the code, check variable values, confirm the logic behaves as expected, all within the IDE. It dramatically speeds up that inner development loop.
I can see that. You catch logic errors much earlier before you even think about deployment complexities. That's a big shift left for testing.
It really is. It lets you focus on getting the core logic right first.
Okay, besides the interpreter, what other standardization things did they add around structured text or configuration that make life easier?
They added a few important pieces for clarity and standard compliance. There's new support for named constants, for instance, which, again, sounds small, but in large projects, using named constants instead of magic numbers makes the code so much more readable and maintainable.
Absolutely, good practice.
And more technically, they bolstered support for standard IEC 61131-3 functions, making it more complete. And critically, they added proper support for var-in-out variables.
Okay, Vernout, let's pause there. For someone maybe not deep in the weeds of 611-313, why is that specific variable type important? What's the practical benefit?
Performance and memory efficiency, big time. Var-in-out is about passing data by reference, not by value.
Meaning you don't copy the data.
Right. Imagine you have a large data structure, maybe an array with thousands of sensor readings. If you pass that by value into a function block, the system has to copy that entire chunk of memory. That takes time and uses up potentially scarce memory.
Okay.
But with var-in-out, you're essentially just passing a pointer or a reference to the original data. No large copy operation. The function block works directly on the original data.
So much faster, much less memory overhead, especially for large data sets.
Exactly. And fast control loops. Passing large structures by value can introduce significant delays or jitter. So supporting var-in-out properly is essential for high-performance applications. It lets you handle complex data efficiently.
Got it. That context makes it clear why that's a key addition, not just a minor syntax thing. Before we move off the IDE, they also mention simplified deployment and monitoring configurations.
Yes, this is another practical helper. You can now store your deployment configurations like IP addresses, target device settings, maybe security keys, and also your monitoring setups directly within the project.
Ah, so instead of everyone on the team having to manually configure how to connect to the 20 different controllers in a work cell every time.
Right. You set it up once, save it with the project. Then anyone who checks out that project gets all the right target info automatically. They can deploy and monitor much more easily without re-entering network details or remembering which port is for what device.
That standardizes the whole deployment process. Seems like it would really help with team collaboration and reducing setup errors.
Definitely simplifies onboarding new team members or just handing projects over. It brings the physical setup configuration under the same version control as the code itself.
Okay, that wraps up the IDE enhancements nicely. Let's pivot now. From the shiny front-end tools to the engine under the hood. FORTIac 4TE. This is the runtime that actually executes on the PLCs, the embedded controllers, the industrial PCs.
Correct. This is where the real-time execution happens. Performance and reliability here are paramount.
So, while FORTE got fewer commits than the IDE, the notes say the changes were focused. What were the key optimization areas?
The team focused on modernizing the core FORTE codebase and its build system. But the really interesting optimization work, from a performance perspective, was aimed at reducing overhead in two very specific places: event processing and data connection handling.
Event processing and data connections. Why are those critical for performance in a real-time system? What happens if they have too much overhead?
Well, in any real-time system, overhead translates directly into latency and jitter. Jitter is the variability in how long a task takes to execute. If processing an incoming event like a sensor changing state or a network message arriving takes an unpredictable amount of time because of overhead.
Then your system response becomes unpredictable,
Yep.
non-deterministic.
Exactly, you might miss deadlines. A safety function might react too slowly. A motion controller might not update fast enough, leading to jerky movement. Same thing with data connections. If copying data between function blocks internally is inefficient, it adds delays to your control loop.
So by greatly reducing overhead in these areas, as the notes say, the 3.0 release should allow for tighter, more predictable control loops.
That's the goal. Lower jitter means you can potentially run control loops faster, achieve higher precision, or simply have more confidence in the timing determinism on your existing hardware. It could enable applications that weren't quite feasible before due to timing constraints.
Which translates to either better performance or potentially using less expensive hardware to achieve the same result.
Precisely. And it's worth noting that modernizing the core codebase and build system for a real-time runtime like FORTE is not trivial. You have to be incredibly careful not to break the real-time guarantees.
Right, it's delicate work.
The fact they tackled this, and the short time frame post-freeze, suggests they're confident in the outcome, points to a serious long-term commitment to maintaining FORTE's performance and suitability for demanding real-time applications.
Okay, that covers the IDE improvements and the FORTE optimizations, but there's actually a completely new piece in 3.0, a whole new component.
Yes, this one is quite interesting. 4diac FBE.
FBE. What is it, and what problem does it solve?
FBE stands for the 4diac FORTE build environment, and it's designed to tackle a major source of frustration in industrial development: managing the build process for multiple different target platforms.
Ah, the cross-compilation headache.
Exactly that headache. Think about it. You might be developing on a Windows machine, but deploying to a Linux-based industrial PC, maybe a Raspberry Pi, and perhaps even a small microcontroller running a dedicated real-time operating system, RTOS.
Each needing different compilers, different libraries, different settings.
Right. Historically, managing all those different tool chains, making sure you have the right versions, setting up the paths, it's complex, time-consuming, and incredibly fragile. You get those, well, it builds fine on my machine problems all the time.
Been there. So how does FBE fix this?
It aims to automate the entire build process for FORTE, for all these different targets. And here's the kicker. It's designed to require no downloads or installs of any third-party compilers or tools directly onto your main development machine.
Wait, no installs? How does that work? Does it use containers or something?
It essentially abstracts away the complexity. It manages the necessary build tools and environments internally, likely using techniques like containers or carefully managed toolchain downloads within its own environment. The key benefit for you is that you don't have to manually install and configure, say, 5 different cross-compilers on your laptop.
Wow. That alone sounds like a huge relief. What about managing configurations for different targets?
That's the other main function. FBE allows you to define and manage multiple FORTE build configurations. One for your Pi, one for your industrial PC, one for simulation, maybe all side by side, on your single development machine.
So you can easily switch between building for different targets without messing up your environment?
Exactly. You select the target profile, hit build, and FBE takes care of using the correct toolchain and settings to produce the right FORTE binary for that specific target. It standardizes the build output, making testing and deployment way more reliable and repeatable.
This sounds like it brings modern CI/CD principles, like reproducible builds, much closer to the industrial automation workflow.
I think that's a perfect way to put it. It removes a major source of friction and inconsistency.
Now, the notes mention FBE is currently available as a beta setup, but integration into the main FORTIAC IDE is planned.
That's right. The standalone beta is out there for people to try now, but the long-term vision is clearly to have this powerful build management capability tightly integrated right into the IDE experience.
Which would really tie everything together. Configure your targets, write your code, test your logic with the interpreter, and then automatically build the correct runtime for deployment, all from one place.
Precisely. It points towards a much more streamlined and unified development workflow, letting engineers focus more on the actual control logic, the value they're adding, and less on wrestling with tools and configurations.
Okay, so let's try to summarize this whole 3.0 release. After 2 years and thousands of commits, what are the main pillars for someone evaluating this? What's the core message?
I'd say it boils down to maybe three key things. First, significant stability and performance improvements deep in the core runtime in FORTE, especially around event and data handling for better real-time behavior.
Range engine tuning.
Second, a major focus on usability and standards compliance in the IDE. Things like refactoring, the structured text interpreter for easier testing, better project validation, and support for things like Veranout, making the day-to-day development smoother and safer.
The developer experience upgrade.
And third, the introduction of FBE. This new component tackles that cross-platform build complexity head-on, automating FORTE builds for multiple targets without needing local toolchain installs. That's a big step towards modernizing the workflow.
Automation for the automation developers?
Kind of, yeah. And it's important to remember this wasn't built in isolation. The team is really emphasizing the community aspect. They're actively asking for help now during this feature freeze period.
So this isn't just a heads up, it's an invitation.
Absolutely. They want people to download the release candidates, test them out, especially the new features like the interpreter or FBE on your specific hardware or target setup. Try the refactoring on your real projects.
And report back if things break or don't work as expected.
Exactly. They have specific issue trackers set up for the IDE, for FORTE, for FBE, and even for the documentation. Feedback provided now in these next couple of weeks can directly influence the quality and stability of the final 3.0 release. It's a real chance to help shape the tool you might be using.
So if you're in this space, now's the time to kick the tires.
Definitely. And, thinking about that new FBE component, it's incredibly powerful, abstracting away so much build complexity. But it also raises an interesting question, maybe something for you, the listener, to consider as you explore 3.0.
Oh.
Given how critical deterministic behavior and absolute reliability are in industrial control, how much should we rely on these increasingly automated, abstracted systems like FBE? When you're managing configurations for safety-critical systems across diverse hardware, where do you draw the line between embracing the convenience of automation and maintaining that deep, hands-on understanding and control over the build process?
Yeah. How does this shift the developer's role and responsibilities when the build system becomes more of a black box, even a very helpful one?
Exactly. What level of trust and verification is appropriate? It's something worth mulling over as these powerful new automation tools become more prevalent in the industrial space.